Hi, this is Miss Claywell with 3.3 perfect squares and perfect cubes. So I'm continuing factoring. Uh, if we look at what I have here, I need to do an ACB tree for number 1. My A is 1. My C is -4. So A times C becomes -4, and I don't have a B. So my B adds to 0. So what two numbers multiply to -2, or multiply to -4 but add to 0? Is 2 and -2. So I'm rewriting 0x as minus 2x plus 2x minus 4. I can pull out a 4 and a 2. So here's my matching, here's my leftovers. So I have an x minus 2 is my matching, x plus 2 is my leftovers. So this becomes x minus 2 and x plus 2. As I look at number 2, I have my A is 1 and my C is 25. So it multiplies to -25, but adds to a B of -5, or a B of 0. I have nothing there, so I have -5 and 5. I'll do those in my color. So I am saying that x squared minus 5x plus 5x plus 25 is the same as what I originally had, and then I can do my grouping. I can pull out an x, I can pull out a 5. So here's my matching. Here's my leftover. That becomes x minus 5x plus 5. Notice this trend. I'm going to fill in this last two for us. This becomes 3x minus 4, 3x plus 4. So if we look at the next part of our notes, it says, what do we notice? I'm going to clean this up a little bit. So we see this pattern of, what do we notice about the binomials being factored? So if we look at what it gave us, everything has a negative in the middle. There's subtraction between them. So I have a negative, 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 negative. They're all two terms or binomials. 4, 25, 16, 9, 1, and 1. All my coefficients are perfect squares. Anything we notice about the factors, any patterns, everything was a square root. So the square root of 4 was 2 and 2, square root of 25 is 5 and 5, square root of 16 was 4 and 4. And then everything it had 1 with addition, 1 with subtraction. So let's summarize this shortcut. That is called difference of squares. Make sure that it has two terms. Make sure that, in fact, our GCF, both terms are perfect squares. And have subtraction between them. You can factor using difference of squares. Finding the square root of each term, put those into binomials. Make sure one has a positive sign and one has a negative sign. In other words, if we do something squared minus something squared, this becomes, we add those square roots and then we subtract those square roots. So that's the pattern we're going to be using through this. If we look at these, step 1, I have two terms. Pull out a GCF. Everything I can pull out at 2x. And then this is the same as an x squared, so I'm just writing it as something squared minus something squared. My b is 4. So then I subtract and add my perfect squares, one with addition, one with subtraction. So I identified the square root of x squared was x, square root of 16 was 4. Looking at this one, I'm going to pull out a -2. I take the square root of 25x squared is 5x squared and 9 is 3. I do one where I add, one where I subtract. Here I have two terms. We're going to pull out a 4. I find it helpful to identify the square root. Square root of 16 is 4. That's our b. Square root of 25 is 5. And then I have an xy. So 5xy. So 4. And then I subtract them. And then I add them. It does not matter if you do the adding in between or the subtraction in between first. So these are all difference of squares. We're going to look at some that may not be difference of squares. We're going to see, so I'm going to pull out an x, or a 5. I have a binomial, 4 is a perfect square, x squared is a perfect square, but I have addition. So this can't be difference of squares. I'm going to pull out a 4x. I have subtraction, so that's great. 3 and 4 are not perfect squares, though. So this is not difference of squares. Last one, I can pull out a 4. I have subtraction, but 5 and 6 are not perfect squares. So this is not difference of squares. Go and flip to the back page. This is asking us to multiply with double distributing or the box method. I'm going to use the box method. I'm filling these in. A to the third minus a squared b. When I look at what cancels out in that, these two cancel out, these two cancel out. So I end up with just a to the third plus b to the third. Here, you can go ahead and try this one on your own. Pause your screen if you need to. So I'm just filling in these cancel out, these cancel out. And that's what I end up with. So what we notice about our answers is I have a to the cube, b to the cube, a to the cube, b to the cube. So I have only cubic terms. So we're going to take a second and identify all of our perfect cubes. Fill these out in a calculator if you need to. I'm going to pause the screen and fill. So these are perfect cubes. Make sure you have those written down. So we're going to write, or our goal is to write this as factors. So I'm going to look for a GCF. I see a 2. And I read this as something cubed minus something cubed. Cube root of 8 is 2. Cube root of w is w. And then I always use these equations here. Yeah. A way to help us remember the signs is SOAP. So this is the same sign as the positive. This is the opposite sign. This is always positive. So I had a plus, negative, negative. Same sign as the original, opposite sign as the original, always positive. Look down here, and this one's negative, so it's the same sign, opposite sign, always positive. So now that I know this is my A and this is my B, I can plug it into the difference of cubes, so I have subtraction. So I'm not going to write an A, I'm going to write A minus B, which is W minus 2. A squared minus A times B